Well, here we go. We're going to construct a wheel. So we can start with a new Sketchpad, or you can, if you're in my class, you know how to get it from the classes folder. Let's just take a point. I'm going to start a random point here. We're going to name it A. Yeah, it's always A. We want to visualize the relationship between diameter and circumference. So let's do this. We're going to lay out this we're going to generate this wheel with a diameter of 10 centimeters, so it will have a circumference of 10 pi centimeters. Let's get to it. From our point, we're going to translate. We're making the path. First off, you see 90 goes up, 0 for our fixed angle. We want to go to the right. And we're going to travel a distance of, what did we say, 10 pi? We could put in 31.4. Now let's just do this. 10 pi. Look at that. Sketchpad knows its stuff. So you could name this point. It's going to come up, of course, A prime, but let's rename it for Z. So our path is going to be from A to Z. And we'll draw it out like that. And I'm going to do one more thing. I'm going to put on the label tool. You know, Sketchpad will label it with a lowercase letter. But I'm going to put in a proper word here. I'm going to put in the word circumference. Because that's what we're doing. We're representing the circumference of the circle. So, next thing. Snap a point there. Snap a point. It's got to travel along AZ. I'm going to label it for the purpose of instruction. And you don't need to do that. You can take it out at any time. But right now you see B moves like that. Now translate that point. Transformers, translate. Translate. This time we're going to go up, which is the direction 90. And if the radius is, or diameter is 10, radius is 5. We'll do this to scale, so we've got 5 centimeters. We could name this point B prime. Let's give it another name. Q. How's that? Draw yourself a circle from Q to B. And you can see now that you have a circle to move along this track. Although tugging on it like this, it looks like it's skidding. We need to add motion, and I'm going to put a random point on there. Let's see what it comes up. My money's on Charlie. There it is, C. So that point C can move along this circle. Very nice. And, well, that's all we need to create the motion, but we have to give it some kind of an effect. So double click on the center of your circle, Q, take C, transform, and rotate 180 degrees. You know what we're doing there is we want to draw a diameter. And I'm going to make it whatever color you want. I want red. And I'm even going to do this. I'm going to click on this. It comes up K, always a lowercase letter. I'm going to write the word diameter, so I can keep track of what's going on here. You know, I think I'll even color code it, make it nice and small, and put it in red. So there it is, a little smaller than that. So right now we've got a diameter. You know, we could put in spokes if you want. Well, hang on, let's just do the fun thing. All we have to do is animate now. We have 2 moving parts. We've got the C, which is going to give us rotation, and either the Q or the B, which is going to move us along our track. So select the 2. I'm going to select the B and the C, edit, action, animation. Animation, well, we're moving left to right. Well, that would be silly. That's going to have to be clockwise. We'll keep the speed medium, and that's going to be, well, that's going to correspond with the speed at which B slides across here, and we'll call that forward. We drew from A to Z, so that's going to be forward. Both are in the medium speed, and we're done. Watch this. We press the button, and you can see the animation. Looks like a wheel. Now, okay, that's probably a little boring, so I'll have to make it a little more exciting to keep your students happy. So let's hide this. Let's hide some of these points here. We don't really need all those labels. We are going to measure. If I measure these 2 linear measurements, look what I get. Measure length. Hey, look at that. You know, wait a minute. Let's do that better. Let's go to preferences. And let's set our preferences to the 100,000th place. Now let's measure the diameter and the circumference. Because you all have pi memorized to at least 6 digits. And we're going to memorize there, or we're going to measure. Check that out. Diameter 10, circumference 31.41593, which, well, casual observer, that looks like 10 pi. The relationship between diameter and circumference. Okay, but let's make it pretty. And it's what my students like is, let's make this into spokes. I'm going to rotate this. I'm going to, not 180, how about 30, like that. And I'll make it a different color. Rotate it again. And let's keep filling in this wheel. Rotate again. And every time I do this, I'm going to change the color. Makes it more interesting. Transform, rotate again. And let's see, we haven't used green yet. No, we have magenta, our favorite. Transform, rotate again. And that's going to complete our picture. Orange. Oh, that's too orange. We have to change that. Okay. Now, when we do this rotation, if we put on some traces, we'll get a fun effect. Watch this. We'll just trace 2 of the colors. Display, trace segments. Oh, and everybody likes that. You can really see that the path of the wheel is it's going to travel that distance, the circumference, in 1 revolution. Now, if you want to do more than that, because I know my guys do, and we could select all of these and put the traces on. Displace, trace, and it makes a real pretty picture. And, if it's not fun, why would we do it? Look at that thing go. All right, I'm going to stop that because I know we want to do another example, get our money's worth. So this time we're going to do a smaller wheel making multiple revolutions. And I'm going to start down here. This time I'm not going to label anything. You get the idea by now. We're going to translate that distance just like we did before. We're going to set our ground track, our distance or direction of 0, meaning to the right, to the east for you cartographers, and our distance. Well, let me see. How about 14 pi? So, yeah, that'll be good. Now we're going to do this. That's our track, 14 pi. And I'm going to put a little up there. I'm moving. Oh, it sounds like Nani causing a commotion out there. But we're going to make a smaller wheel. Transform, translate. We want 2 centimeters for a diameter. So let's give it a radius of 1. 1 and done. You can see it right there. Beauteous. Maximus, right there. And you can see that that's going to make multiple laps, like those little wheels they use to measure your track. And it's going to go around and around and around. And let me put a point on there. And that's your moving point. So we could animate this, but let's make this into spokes because it looks better that way. I'm going to rotate this, transform, rotate, 72, 360 divided by 5, 72 degrees. You all know that. And let's rotate again, and again. And we're just about ready, almost done. Now, make it a little bit different on this one. Let's take a point on the circumference and we're going to dilate it. Well, you'll see why in a little bit. I'm going to go 3 quarters, as we say on the East Coast, 3 quarters. And right there, that means it's 3/4 of the way from the center to the circumference. I've got this point. I want to put traces on that point. Let's trace that point. Now I'm going to animate these 2 points. Oops, just like we did before. Edit, action, animation. Clockwise, medium, and forward. Medium. Are you ready to press the button? I know you are. Look at that go. Now that is fun. Let's count the laps. What did we say? A diameter of 2, circumference of 14 pi. What do you think? 7 revolutions? Let's see if it, count them out, and there you go. 7 revolutions, perfect.